So let's see what we got. Write a two-column proof for the following. So they tell us that A is congruent to E. And then they also give us here that the fact, or they don't give us this, but we kind of assume that all vertical angles are congruent. So by angle similarity, these two triangles are congruent. Now that's not actually what they're trying to prove. They got this weird stuff with multiplication of the sides, so that's kind of strange right there. And I'll show us how to get to it on this first example, and then hopefully it kind of makes sense. Okay. So anyways, the statements will say angle A congruent to angle E. That was given. We also said, and be careful, a lot of people want to say angle C is congruent to angle C, but I don't know what you mean by angle C, so I have to say ACB is congruent to angle ECD. That was because of vertical angle theorem. Okay. And then we said that the triangles were congruent, so we'll say triangle ACB, I guess, is, whoops, I wanted to say congruent, they're actually similar, is similar to triangle ECD. That was the angle similarity, whoops. I think that's actually a postulate. Okay. Now after this, if you haven't seen this before, this is where it kind of gets weird here. So we know after our triangles are similar, we know that the sides have to be proportional. So those two sides need to be the same ratio as these other two sides here, BC and CD, I guess. Okay, so we're going to write that as a ratio. So I'm going to write here, and it's kind of small, so we'll have to go AB to, I guess, CE. That needs to be the same ratio as DC. I'm sorry, nope, not DC. I got to start with the small one, BC. I apologize. To CD. All right, now I've seen different teachers put different things here for this. In my class, we say, that's the definition of what it means to be similar. Similar figures. You can say similar figures have proportional sides. I'm just going to put definition of similar, I guess let's say polygon. Or you could even put triangle there. Okay. Now, to get from D to the step here that we're trying to prove, what we want to do here is think about cross multiplication. We want to say that cross products are the same right there. So we're going to go write this here. Let's say AC times DC, right? This has to be our last step if we're proving something. BC. And we just say, you can say cross product property. Some other teachers even accept cross multiply. Does not matter. Just check with your teacher what they want you to see or want you to write. All right, I know it's kind of long. Got a couple more here. So let's see here. So they give us right here. They give us this ratio here, which is kind of weird. They say we have AB and then we have that to AD. Apparently that is, let's get the highlighter again, that is equal to AC to AE. So what this means right here, if you want to write this next to this, that just means the sides are proportional. So those sides are proportional. You have two sets of sides proportional. And guess what's right here in between your two triangles that you have? You have a shared angle. Okay, so then we can say by side, angle, side, that these two triangles are similar. So let's go ahead and put all that there. So let's see, we got AB to AD equals A something, I guess AC to AE. That was given. We can say angle A, since it's a shared angle, we can say angle A is congruent to angle A. You can use 3 letters if you want, but we know what we're talking about there. So that is the reflexive property. Usually we use that reflexive property when there's something that's shared. And then we can say that the two triangles are similar. So we can say, I guess, triangle ABC is similar to triangle ADE. And that is by side angle side similarity. I think that's a theorem. Can't remember. The side angle side similarity, put something along the lines of that. Now notice here they're switching gears. They want us to say, instead of leftover angles are congruent, which is technically true, they want us to show that these sides have to be parallel. So notice the two angles that I just marked right there. The one next to B, I guess ABC, and then ADE. Notice that both of those are corresponding angles. If you're looking this, like the AD is your transversal, and then here's your two lines. Those are corresponding angles. And since my triangles are similar, those corresponding angles have to be congruent. So we're going to say angle, I guess ABC is congruent to angle, ADE. Alright, you can say something about definition that goes back to, well, we're similar, so therefore everything else is, proportional or congruent. So we can say definition of similar polygon. And then finally, since we know our corresponding angles are congruent and they're touching two lines there, we can use a converse theorem. We can say angle, or actually, I'm sorry, we've proven that the lines are BC parallel to DE, right there, and then we can just say, what do we put here for that? Oh, two different ways you can do it. In my class, we say the corresponding angles theorem converse, which proves lines are parallel. Some of you guys, your teachers, make you write out the if-then statement. You can write, if corresponding angles are congruent, then the lines are parallel. So just depending on your teacher, one or the other, right there, either one. Okay, I think we got, two more. Alright, given, what do they give us? They gave us the two sides, AB to DC is proportional or similar, whatever you want to write, to AC. Let me use two different colors. AC to CE, right there. Notice you got parallel lines. They also told us that. Therefore, we have corresponding angles congruent. We can say a side angle side, that these two triangles are similar. So let's take all that stuff there. Write it down. AB, DC, AC to CE, given. We also have the other given part. So I think they want us to use two lines here, similar to CD. It's also given. We automatically knew that angle A is congruent, and I can't say angle C, I don't know what we're talking about, so we'll say angle DCE. Those are congruent. We can say that is the corresponding angles theorem. Or if your teacher tells you to write out the full conditional statement, here I guess we'll keep the same. We can say if lines parallel, then corresponding angles are congruent. So just depending on your teacher, either one of those. Alright, so then we can say that the two triangles are similar. So we'll say triangle ABC similar to triangle CDE. You say side, angle, side, similarity theorem. And then, last but not least, they're trying to prove that these leftover two angles right here, ACB, is congruent to angle CED. And we say, well, once we prove the triangles are similar, the leftover stuff, the leftover angles, I guess I should say, are similar. So I'm going to put definition of similar polygon. Okay. All right, one more. Okay, given. We're given that two sides are actually congruent here in this case. So we have FG is congruent to GH. Ooh, that's interesting right there. And then we also have JK is congruent to KL. So these two sides are congruent. And then also we have F is congruent to angle J. Look at this. So this kind of looks like you got some side angle stuff going on right here. But what we need to realize here, this is technically an isosceles triangle. So therefore we know F is congruent to H. We also know J is congruent to L. So now we know all of these angles are congruent to one another. Alright, since you have two angles that are congruent, we can say by angle that these two triangles are similar. Okay. And then after that, then we can prove that the two triangles are similar here. So there's a bunch of lines here on this one. So let's see. The first thing we said was given. We said that the two triangles were isosceles. As far as what we could write there, let's just say it's kind of like it's dealing with your base angles. And there's something called the base angles theorem that says if your base angles are congruent, then the triangle is isosceles. So I'm going to put base angles theorem for an isosceles. And I'll just kind of abbreviate that for an isosceles triangle. Okay, we also were told, let's see, H is congruent to F, so that's the base angles theorem, actually. Oh, you know what, now that I think about this, I think I'm jumping the gun on the base angles theorem, so I'm sorry, scratch that. It's, for step 2 here, this should, if you have two sets of congruent sides, I'm just going to write here two sets of congruent. So let me write two sets of congruent sides. Right? And since the two sides are congruent, that's the definition of what isosceles is. You could even probably even write that. You could also write definition of isosceles. Okay. Anyways, so going back, okay, so we have the base angles theorem. H is congruent to F. As far as F and J are congruent, that was congruent because it gave us that, so that's given. We know then that H is congruent to J, so I guess you can say there, oh yeah, that's the transitive property there. They're all congruent to one another, essentially. J and L were congruent because that was also the base angle theorem. And then H is congruent to L. So that's also going to be your transitive property again. Kind of making a bunch of conclusions. Alright, and then therefore, since you have two sets of congruent angles, then we can say by the angle similarity theorem that those two triangles are similar. And I believe that is it.